Welcome back, everybody. We are going to jump ahead to lesson 17 of Unit 3. And in this lesson, we're actually going to relearn something that you've already learned in a previous math course. And that is a method of solving quadratic equations called completing the square. We're going to relearn it again. The difference between now and the first time you learned it is that now your equations are going to have complex number solutions, whereas the first time you learned about completing the square, your equations had real number solutions. You're going to find that despite complex numbers being involved, the method is not going to change. So I have two examples here, and I also have the steps for completing the square in case you forgot on the screen here. So let's go ahead and go right into number one. So we have x squared plus 6x plus 13 equals 0. The first step is to move the constant term to the right-hand side. Move the constant term to the right-hand side. So in this case, the constant term is 13. So I need to move plus 13 over, and I'm going to do that by subtracting 13 from both sides. So that gives me x squared plus 6x equals 0 minus 13, which is, of course, negative 13. So that's step one. Step two, divide the coefficient of the x term by 2 and then square it. Divide the coefficient of the x term by 2 and then square it. So our x term is right here. The coefficient of the x term is going to be positive 6. So take the coefficient of the x term, divide it by 2. So 6 divided by 2 is 3, and then square it. So 3 squared equals 9. So take the coefficient of the x term, divide the coefficient of the x term by 2, and then square it. When we do that, we end up with 9. That's step 2. Step 3, add that number to both sides of the equal sign. So we're going to take the number that we got, 9, and we're going to add that to both sides of the equal sign. So on the left-hand side, that's going to be x squared plus 6x plus 9. And on the right-hand side, remember on the right-hand side, I had negative 13, and now I'm going to take negative 13 and I'm going to add 9. Well, what's negative 13 plus 9? Use a calculator if you need to. There's no shame in doing so. I will never stop you. So negative 13 plus 9 is negative 4. So when I add 9 to both sides, I end up with x squared plus 6x plus 9 equals negative 4. Okay, so that's step 3. Step 4, convert the left-hand side to factored form. Remember that add multiply thing that I've done in the past. So take the left-hand side, which in this case is x squared plus 6x plus 9, and we're going to convert that to factored form. So in this case, I am looking for two numbers that add up to 6 and multiply to 9. So two numbers that when I add those two numbers, I get 6. And when I multiply those same two numbers, I get 9. In this case, that's going to be 3 and 3. If you're not sure, there's no shame in checking. 3 plus 3 is equal to 6, and 3 times 3 is equal to 9. Okay, so the factors on the left-hand side, and I'm going to go up here to do that, is going to be x plus 3 and x plus 3. Essentially, I'm going to get x plus 3 twice. Now think about what that means. I get x plus 3 times itself. What is the mathematical term for taking something and multiplying it by itself? The mathematical term is squaring. X plus 3 times x plus 3 is really x plus 3 squared. Okay? So when I factor, I get x plus 3 twice, x plus 3 times itself, which is really x plus 3 squared. So that is step 4. Convert the left-hand side to factored form. I'm going to give you a hint. The reason why it's called completing the square is that when you convert the left-hand side to factored form, you should always get the same factor twice. X plus 3 twice, or x plus 3 squared. So that's why they call it completing the square. Now that I've done that, I can do step 5. Solve the resulting equation by square rooting. In other words, solve the resulting equation by taking the square root of both sides. Now, why am I going to square root both sides? Because squaring and square rooting, as we've talked about, are opposites of each other. So in this case, on the left-hand side, the square root and the squared are going to cancel each other out. They're going to cancel each other out, leaving me with x plus 3. So the square root will cancel out the squared, the exponent, and leave me with x plus 3. So when I square root the left-hand side, I end up with x plus 3. On the right-hand side, I have the square root of negative 4. This is where complex numbers comes in. Okay? The square root of positive 4, if it were the square root of positive 4, we would say that the answer is positive and negative 2. But because we're dealing with the square root of negative 4, it's going to be positive and negative 2i. Positive and negative 2i. Okay? So I end up with x plus 3 equals positive and negative 2i. Now, what does that mean? The positive and negative. That means I'm going to solve this equation. I'm actually going to solve it twice. All right, I'm going to solve the equation x plus 3 equals positive 2i, and I'm going to solve the equation x plus 3 equals negative 2i. That's where the positive, negative, the plus minus comes in. So I'm actually going to solve it twice. If I solve it with positive, if I solve for x here, I'm going to subtract 3 from both sides, okay? And I end up with x equals 2i minus 3. Now remember, when we write out our answers, when we're dealing with complex numbers, I've mentioned this in previous lessons, when we write out our answer as a complex number, we always write the real number first and the imaginary number second. So in this case, the real number is minus 3, and the imaginary number is 2i. So I'm going to rewrite 2i minus 3 as negative 3 plus 2i. All I did is I switched around the order, okay, so that I have the real number first and the imaginary, the I term, second. So the first solution is negative 3 plus 2i. All right. Now if I solve it again, where the 2i is negative, I'm still going to subtract 3 from both sides. So I'm going to do the same thing, except this time I'm going to end up with x equals negative 2i minus 3. All right, and if I switch around the order, the real number is negative 3, and the imaginary number is negative 2i. So the second solution in the proper order is negative 3 minus 2i. So my two solutions to number 1, it's a quadratic. So remember, a lot of times quadratics have two solutions. The two solutions are negative 3 plus 2i and negative 3 minus 2i. Okay, so that's it for number 1. Let's do the same thing now, but now let's do number 2. Okay, so we'll follow the same steps again. So now we have x squared minus 10x plus 50 equals 0. So step 1, move the constant term to the right-hand side. So the constant term in this case is positive 50. So to move that over, I'm going to subtract 50. I'm going to subtract 50 from both sides. So that gives me x squared minus 10x equals 0 minus 50. So x squared minus 10x equals negative 50. Step 2, divide the coefficient of the x term by 2 and then square it. So in this case, what is the coefficient of the x term? That in this case is negative 10. So divide the coefficient of the x term by 2. So negative 10 divided by 2 is negative 5. And then square it. Well, what's negative 5 squared? Negative 5 squared is negative 5 times negative 5, so positive 25. Okay, remember when I square a negative, I get a positive. So x, take the coefficient of the x term, divide it by 2, then square it, we get 25. So that's step 2. Step 3, add that number to both sides of the equal sign. So on the left-hand side, that is x squared minus 10x plus 25. On the right-hand side, remember on the right-hand side, I had negative 50. So it's going to be negative 50 plus 25. Well, negative 50 plus 25 is negative 25. So x squared minus 10x plus 25 equals negative 25. So that's step 3. Step 4, convert the left-hand side to factored form. So once again, I need two numbers that when I add them together, I get negative 10. And when I multiply those same two numbers together, I get positive 25. So two numbers that add up to negative 10 and multiply to positive 25, that's going to be negative 5 and negative 5. Okay, negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is positive 25. So my two factors on the left-hand side are going to be x minus 5 and x minus 5. Okay? Just like in the first problem, just like in the first example, notice I got the same factor twice. So the same factor twice, I can now take it and rewrite it as x minus 5 squared. Because x minus 5 times x minus 5 is really x minus 5 squared. That, again, when you're doing completing the square, that should always happen. So I have x minus 5 squared equals negative 25. Okay. That was step 4. Solve the resulting equation by square rooting. So square root both sides. So just like before, the square root is going to cancel out the squared, and that's going to leave me with x minus 5. On the right-hand side, the square root of negative 25 is going to be positive and negative 5i. Remember, we treat it as if it were a positive square root and tack on an I at the end. So if it were the square root of 25, it would be plus and minus 5. So the square root of negative 25 is going to be plus and minus 5i. All right, so I end up, when I put all this together, I end up with two equations. I end up with x minus 5 equals 5i, and x minus 5 equals negative 5i. All right, so let's solve it first when it's positive. So x minus 5 equals 5i. Add 5 to both sides. Okay. So x equals 5i plus 5. But remember, I have to switch around the order so that the real number is first and the imaginary number is second. So 5i plus 5, if I switch around the order, the real number is 5 and the imaginary number is 5i. So I can switch around that order and make it 5 plus 5i. There's your first solution. Your second solution, x minus 5 equals negative 5i. I can, once again, add 5 to both sides of the equal sign. And I end up with x equals negative 5i plus 5. And if I switch around the order, okay, what is my real number? My real number is positive 5. And my imaginary number, my I term, is negative 5i. So in the proper order, that's going to be 5 minus 5i. So my two solutions are 5 plus 5i and 5 minus 5i. Remember, I talked about this in a previous lesson, that when you have two complex numbers that are pretty much the same with the exception of one having a plus in the middle and one having a minus in the middle, those are called conjugates. Okay? Let's go back and look at the first equation. Notice in the first equation, I got negative 3 plus 2i and negative 3 minus 2i. Again, those were conjugates of each other. Do you think it's a coincidence that I did two equations here by completing the square, and when I solved them, my solutions were conjugates? Negative 3 plus 2i, negative 3 minus 2i. 5 plus 5i, 5 minus 5i. That is not a coincidence. So that is another way that you can get a good idea of whether you're doing the problems correctly or not, is when you get to the end, your two solutions should be conjugates of each other. Again, conjugates mean that they look pretty much the same with the exception of having a plus in the middle versus a minus in the middle. So that was the same for both of these problems. And that is it for lesson 17.